As we mentioned before, we shouldn't use equivalence operator equal to compare two objects' values. Because when we compare using equal, we are actually compare objects' memory address, not their values. In this example, a name and another name are strings, and the program tried to compare if those two names are the same using equal, and this is wrong. Equal comparing the two objects' memory address, because there are two objects, they located at different memory addresses. This is why the comparing result says they are different, even they have the same text for names. In Java, there are several classes we can use to work for the text. First is a character. Character is a class whose instance can hold a single character value and whose methods manipulate and inspect single character data. Then string class. String is a class for working with fixed string data, that is, unchanging data composed of multiple characters. A string in Java is actually an object which contains methods that can perform certain operations on strings. Then we also have a string builder and a string buffer. Those are classes for storing and manipulating changeable data composed of multiple characters. Those are the standard methods for testing the values of characters. There are many methods of character class method. These methods usually begin with a is, such as a is uppercase, so it returns a Boolean value that can be used in comparison statements. The methods that begin to, such as a to uppercase, return a character that has been converted to the stated format. For example, to uppercase, so it returns the uppercase equivalent of the argument. In this example, it illustrates how to use those class method. We know class method means they're not associated with object, right? So when we use it, we don't create the object. We just call the class name and the dot, then method name. So in this example, we have a public class character info, and in the method main, we first have a character called a character. The value is a capital C. Then we have a system.out.println. We print out the character is uppercase C. Then we call this method is uppercase. So character, and it must be uppercase C, character dot is uppercase, and we pass the parameter a character. So character dot is uppercase a character will return a Boolean value. So all those methods we mentioned before, to, is, they are all class methods. So we use a character, then dot, then we call the method, and we pass the character parameter. Let's take a look at string. String is a class, and each created string is an object. A string variable name is a reference. That is, a string variable name refers to a location in memory rather than a particular value. In this figure on the left, when you declare a string, such as a string a greeting equal hello, a greeting doesn't hold the characters that make up hello. Instead, it holds a memory address where the characters are stored. So hello is stored at memory address 26040. So a greeting contains that address 26040. If we assign bonjour to a greeting, bonjour is stored at the address 32564. So after we have the assignment, now a greeting will contain the new address where bonjour is. It's the 32564. We see when we compare two strings, we shouldn't use the equal sign because it's comparing the memory address. So we want to comparing the contents we should use the string class equals. The string class equals method evaluates the content of string object to determine if they are equivalent. The method returns true if the objects have identical contents, no matter how the contents were assigned. In this example, it shows a compare string application. First string is a name, which is common. Then we prompt for the user to enter another name. It will be assigned to variable another name. Then we have the if statement. If a name dot equals another name, we output they are equals. Otherwise, we output it doesn't equals. We can see we use equal method with a string object. Right here we say a name dot equals. So that means this method is not a static method. It is used with the object. It returns a Boolean value, and you will need to pass one argument, string argument, to equals method. There is also a equals ignore case method. So as the name implies, this method ignore case when determining if two strings are equivalent. The Java string compare to method compares two strings in the dictionary order. The comparison is based on the Unicode value of each character in the strings. The syntax of a compare to is similar as an equals method. So we first have a string object, then dot, compare to, then we pass a string argument. So we'll compare those two strings. In this example, if a word and another word, they are same, it will return 0. If a word comes before another word, they will return a negative number. If a word is come after another word, it returns a positive number. So those are based on dictionary order. If you need to compare two strings, ignoring case difference, we can use a compare to ignore case method. Programmers often are confused by the difference between empty strings and the no strings. We can create an empty string named word1 and two no strings named word2 and word3. So the word1 references a memory address where no characters are stored. The no string word2 use the Java keyword no so that word2 doesn't yet hold a memory address. The unassigned string word3 is also a no string by default. Empty strings word1 can be used with the string method we described before, but no string word2 and word3, they are no string, null. They are not able to use the method we described before. There are many string methods. For example, the length method. It returns the length of a specified string. So if you want to use some method, you can Google string method in Java and will show you the table or the available methods. Character add method, it returns the character at a specified index. So it requires an integer argument. So for example, if we supply the argument as 1, character at 1, so that's index 1. So actually we'll return the second character in the string because the index starts from 0, right? 0, 1, then 1 is the second character. The ends with method checks whether a string ends with the specified characters. And the starts with method to check whether a string starts with the specified character. So we pass string argument, and the method will return true if the string ends with the specified characters. If it will false if the string didn't end with the or start with the specified characters. The replace method searches a string for a specified character, and it returns a new string where the specified characters are replaced. In this example, we have a my string. It is hello. So my string dot replace Then we pass two arguments. The first one is the character we want to replace, so we pass L. Second one is the P, so we replace all L in the string with P. So my string will become HEPPO. The toString method will convert a number or something else to a string object. Though in this example, we have integer, sum integer equal 4. So if we call integer dot toString, then we pass the integer 4, it will convert the integer 4 to string object 4 and assign to the variable the string. The substring method takes two integer arguments, a start position and an end position, that are both based on the fact the string first position is 0. The length of the extracted substring is the difference between the second integer and the first integer. If you call the method without the second integer argument, the substring extends to the end of the original string. In this example, we can see several string methods. We have a string name, then we can see name.length, name.substring, name.character@. The region matches method can test if part of the string's regions are equal. The method has 5 arguments. The first one is a Boolean argument. If it is true, it will ignore case when comparing characters. If it is false, it will not ignore cases, so case sensitive. The second argument is the starting offset of the subregion in this string. Then the third argument is the other string object. The fourth one is the starting offset of the substring subregion in the string argument. And the fifth argument is the length, the number of characters to compare. In this example, we have a str1, the string object. It contains hello, comma, then space, how are you? The second string object, str3, it contains HOW in capital case. Then we system.out.print. Then we call the method string1.region matches. Then we pass the arguments like a true, that means we ignore case. Then 7, that's the offset that is starting from the string 1. So 7 is a capital H in hello, how are you? The second H, HOW, that's a capital H, that's a starting position. Then string 3, that's the argument for the other string we are going to compare. The 0 is the starting position at a string. So start from HOW, starting from H. Then the length of the character is 3. So we are comparing 3 characters from the offset. It will return true because we ignore case here. We can use the pass method to convert the string to a primitive data type. For example, we can say pass integer, pass double, and those are static methods. So it starts from int or from double. In this example, we have a int integer x, and we assign integer that pass int 9. So 9 is a string object. It's enclosed in double quote. Then after we call integer.passInteger, it will convert the string 9 to integer 9, and then we assign to variable x. For the second line, double C equal double.passDouble 5. So we convert the string 5 to double type. So the output will be 5.0 because it's a double type. The third one, integer b equal integer.passInt 444 and 16. So we will first convert the string 444 into an integer 444. Then the 16 means integer as a hexadecimal format. So the output is 1095. That's the hexadecimal representation of 444. Java provides three classes to represent a sequence of characters. We have a string, string buffer, and a string builder. The string class is an immutable class, whereas string buffer and the string builder classes are mutable. What does mean immutable? That means unchangeable. So for example, if you use a string class, you first assign hello. So you have a memory location in that string object and a reference to hello. Then later you want to assign goodbye. So hello is still there. Then you just assign a new memory location where goodbye is to the string object. So if you perform many such operations with strings, you end up creating many different string objects in memory, which takes time and resources. You can use string buffer or string builder, and there are some differences. The string builder is more efficient. String buffer is a thread safe. If you have multiple threads of execution in the program, you should use a string buffer. If the program only contains a single thread, we should use string builder. Java allows multiple threads, which are units of processing that are scheduled by operating system, and that can be used to create multiple paths of control during program execution. In this example, we first create a name string object. We have a string builder, name string equal new string builder. Then we pass the 7 characters Barbara. So we should use a new keyword for creating the string builder object. To find the capacity of string builder object, we can use capacity method. Here we have an integer name string capacity equal name string dot capacity. The capacity is not the string length, it's the length of the buffer, which is the memory block that contains this string builder object. The capacity of name string is 23. It's not 7. You still can use the length method to return the number of characters the string builder object contains. Because we say unlike the string object, the string builder object is changeable. So the length can be changed. And here we can use setLength method. We have a name string dot setLength 20. So remember the name string contains Barbara, which is a 7 character. After we use name string dot setLength 20, the name string will be 20 character long. The first 7 characters are still Barbara. The remaining 13 characters are no character. String builder objects are like string objects, except they can be modified. Internally, these objects are treated like a variable length arrays that contain a sequence of characters. At any point, the length and the content of the sequence can be changed through method invocations. So if you need to, for example, concatenate a large number of strings, appending to a string builder object is more efficient than string object. String builder parentheses, then we pass no argument. That creates an empty string builder with a capacity of 16. So that's a default capacity, 16. If we call string builder, then we pass an integer capacity that creates an empty string builder with the specified initial capacity. And we have a string builder, we pass a string. It creates a string builder whose value is initialized by the specified string, plus an extra 16 empty elements trailing the string. So if we are going to create a string builder object, we say string1. We can say string builder string1 equal new string builder. Then we have three kinds of, we pass no parameter, we pass an integer for capacity, or we pass a string. There are many string builder methods. For example, append method. It adds characters to the end of a string builder object. In this example, we have a string1.append Java. So Java will be appended at the end of the string1. Other methods like insert method, it adds characters at a specific location within the string builder object. And the set character at method, it changes the character at a specified position within a string builder object. And the character at method, it accepts an argument that is the offset of the character position from the beginning of the string and return the character at that position. You can Google string builder methods in Java